MRP, Material Requirements Planning. That's the module we are going to discuss. I'm going to interact with you on MRP. When we are talking about planning essentially one perspective is to set the dates, start and finish dates for the beginning of an activity and end of an activity. So, if we are looking for planning, there are different approaches for going for planning. One such approach is what we are going to look at, which is hierarchical approach to planning. In this, we are going to look at something called monolithic planning. Now, consider a very moderate sized company which is possibly making about 50 products, each with 400 parts. These parts we are talking about only manufacturing parts, not the bought out finished items, and each part per year possibly could be made in several batches, but we are essentially making a very modest assumption that each part is made in 2 batches per year, and each such batch as it goes through the shop floor for manufacture might require several operations. If 100 and above is not uncommon, but we are making a modest assumption about 50 operations, and for each such operation we have a start and finish date. So, how many dates are we going to decide as a part of the planning exercise? That is what we see here, 50 products, each with 400 parts, each part average 2 batches, each batch average 50 operations, each operation requiring 1 start, 1 finish date. Together it is 4 million, what we have shown it as 4 e to the power of 6 number of dates that we have to decide. So, what does this mean? First thing, it requires huge computational power. We also need to have good forecasting accuracy. Please remember, we are doing the planning for an year. So, before the planning year starts, we need to have a very accurate forecast for all the items, resources and demand right in the beginning of the year till through the end of the year, which essentially is extremely difficult and if possible. Beyond forecast accuracy, we also have to understand one very crucial item, which is what we call it as organizational hierarchy. When we are doing the planning, essentially what we are talking about here is, I need to have capacity, I have to plan for it. After capacity planning, somebody has to decide the batches, batch sizes, and then I have to look at shop floor planning when the operations are going to take place in the shop floor. So, all these 4 million decisions that we are talking about are actually happening right across the organization in different parts, maybe capacity in central planning, batch size determination in production planning department, operation scheduling dates and shop floor planning, and there is material movement, there is inspection, resources availability. All these decisions are happening in different units in the organization, but we are trying to put all the things in one single model. That is why we call it as monolithic model of planning. So, this model, while it may give some optimal solution, the best solution possible, but possibly it does not reflect the entire organizational hierarchy. So, what all we have looked at here is that this planning model possibly is suitable where complexity is less, uncertainty is less. For example, if we are talking about manufacturing huge machine tool manufacturers, something like huge lathe, the parts are few, but each part takes very long time for machining. So, in such cases where the complexity in terms of number of parts is very less and even demand uncertainties are relatively less, probably this monolithic planning is good and it gives us, as I said, best optimal solution. but in reality that's not the case. There will be a lot of complexity of the parts, there is a lot of uncertainty in resource and demand. So we will not have adequate computational power, we will not have adequate forecast accuracy, and there is a need for us to look at organizational hierarchies to be truly reflected in our planning model. So what is an alternative for this monolithic planning? And that's what we begin with, this alternative approach that we will come to call it as a hierarchical approach. This is where, let's take a small example. Think of a product like radios. Radios are radios, but there are different types of radios. We can classify them as single band radio, 2-band radio, 3-band radio, or 4-band radio. Now within each band radio there are different models that are happening, and each model is sold in different regions. So if you notice this, we are actually talking about some kind of levels of aggregation that are happening across the hierarchies. For example, different models are clubbed together as a band, and different bands of radios are put together as a generic product called radios. So in this diagram what you are seeing, we are actually talking about bottom up, the level of aggregation is going up, and we will also have something to say about it, is what we call it as length of planning horizons that we can consider across levels of aggregation. Why are we talking about levels of horizon? This is essentially because our forecast accuracies significantly vary with horizon lengths. So look at this hierarchical approach to planning. We have now partitioned entire planning into different hierarchies. As you see, capacity planning, APP, which is aggregate production planning. Then we are talking about disaggregation and master scheduling. Together we will call it as master production scheduling. And then we talk about MRP, and then we talk about operations scheduling. So these are different hierarchies that we use in the planning model. Now each level of the hierarchy, if you notice in the second column, is essentially focusing on one item at a time. Capacity planning is essentially looking at resource. Aggregate production planning is focusing on product families or product groups. Master production schedule looks at only products, and products are made out of parts or components, which is the focus for MRP. Each part has to be made based on several operations. Like for example, if I have to make a particular knob for a radio, I may have to first do the turning, then some milling, then I may have to drill a hole in that. So these are different activities which we call it as operations. So we have now looked at the entire product manufacture in a hierarchical manner, whether you look at top down or bottom up. Let's see the bottom up approach. I have several operations at the lowest level which produce certain parts. These parts are put together using MRP to products, that is master production scheduling. Different products, depending on the groups, we call it as product families, that product groups, and hence these product groups they need certain kind of resources. For example, if I go back to that radios example, whichever be the model, whichever be the brand of the radio I am making, the printed circuit board assembly is just one resource. So in capacity planning, that's what I look at in terms of how many square meters of printed circuit board I can make, or how many square meters of a printed circuit board I can assemble. So that is the way we interpret the focus related to a particular hierarchy. So now you see that capacity planning, the level of aggregation is the highest, going all the way down to lowest in operations at the hierarchy of operation scheduling. Now comes the crucial issue. When we are talking about capacity planning, typically we look at fairly long planning horizons. When you are looking at long planning horizons, and we are also talking about the forecast accuracy requirements, since we are talking about a fairly aggregated level, long horizons, even if forecast accuracy is low, our decision making quality is not adversely affected. In contrast, compare the operation scheduling. Operation scheduling is typically done probably for a shift or for a day or at most for a week, which means our planning horizons are very short, and I need forecast accuracy to be pretty high, which I can always get it because my horizons are short. So, what is it we have done in this hierarchical approach to planning? We have partitioned the problem into various hierarchies and then trying to find the best solution possible at each hierarchical level. The same thing possibly we can understand in a different way. What is capacity planning doing? It is looking at year as a time period, possibly for next 4 or 5 years. In this diagram, we are showing year 1, 2 and 3. So, the decisions that are made at this level of hierarchy is essentially to look at each year how much capacity do I have to provide. Now, take for an example, I have chosen year 2, some capacity acquisition is decided. Now, that we disaggregate into the next level of aggregate planning. So, that year 2 is then split into, let us say, 4 quarters. Of course, quarter 4 is not shown in the diagram, but we are talking about each one quarter 1, 2, 3. Now, if you look at that radio, if you recall that radio example, what we are then talking about is a circuit board manufacturing capacity for year 2 is fixed, and how is that going to be utilized in different quarters, quarter 1, quarter 2, quarter 3 and so on. Now, let us look at quarter 2 of aggregate planning. So, we have provided for how we are utilizing the circuit board manufacturing capacity. That will in turn be disaggregated into the next level of hierarchy in our planning, which is master production schedule. So, quarters are then disaggregated into month 1, month 2, month 3. So, at each stage we have aggregated the problem complexity has come down, feasible to solve. So, computational power problem is not an issue, forecast accuracies are manageable, and organizational hierarchies are truly reflected. So, what is the implication of this hierarchical approach to planning? This is how we will summarize this. Planning is now partitioned into various hierarchies. Each hierarchy needs less computational power, accurate forecasting for the respective horizon is feasible, planning hierarchies reflect organizational hierarchies. But then what is the problem? We have partitioned the problem. That is the problem. When we have partitioned a problem, even if we have got the best solution, optimal solution for each part, together they do not form the optimal solution for the total problem. For example, I have designed the capacity planning the best, we have solved the aggregate production planning best, but the best for each of these two modules put together in the combined system may not be the optimal. So, we have to do something about it to take care of that. And that is where, when we have adopted this hierarchical approach in the interest of solving the problem and in the interest of making the forecast accuracies feasible, we also have to do something when we are integrating the solutions. And that is where we look at the planning framework like this. We have capacity planning, and next level we have aggregate production planning, then we have master production scheduling, and by this time we should realize that we have arrived at master production scheduling by looking at what type of products when to make based on the capacities that we have. based on the concerns that we have from the operations management, but the products have to be sold in the markets, and markets would have its own demand based on the sales planning. So, to combine these two, we have what is known as sales and operations planning managed by using demand management. After master production scheduling is done, then we look at material requirements planning, then we look at operation scheduling. But in this hierarchy, as we said, partitioned problem together may not give optimal solution. We have to have a mechanism to integrate these various hierarchies, and that is what we call it as MRP2, manufacturing resources planning. Because the acronym turns out to be the same as MRP, we call this as MRP2 to differentiate from material requirements planning, which is MRP. So, what is it we have done in this entire session? We tried to look at what are the different types of approaches for production planning possible. We fundamentally looked at two things. One is monolithic planning, another is hierarchical approach to planning. While monolithic planning may be very good and the best possible, best prescribed, but when the complexity is less and when there is less uncertainty. However, in normal circumstances where complexities are high, uncertainties are high, we resort to this hierarchical approach to planning. And in this comprehensive framework of planning, what in this module we are going to specifically focus on is material requirements planning, MRP.